Derived types. A derived type is a special form of data type that can encapsulate other built-in types as well as other derived types. It could be considered equivalent to struct in the C and C++ programming languages. Example of a derived type: type, name, members, end type. Type general structure. The general structure of a type is the following: type, attribute list, name, parameterized declaration list, parameterized definition statements, private statement or sequence statement. Member variables, contains type-bound procedures, end type. The attribute list may refer to the following: access type that is either public or private bind. C offers interoperability with C programming language. Extends parent, where parent is the name of a previously derived type from which the current derived type will inherit all its members and functionality. Abstract, an object-oriented feature. If the attribute bind, C, or the statement sequence is used, then a derived type cannot have the attribute extends and vice versa. The sequence attribute may be used only to declare that the following members should be accessed in the same order as they are defined within the derived type. The use of the statement sequence presupposes that the data types defined below are neither of allocatable nor of pointer type. Furthermore, it does not imply that these data types will be stored in memory in any particular form, i.e., there is no relation to the contiguous attribute. The access type attributes, public and private, if used, declare that all member variables declared below will be automatically assigned the attribute accordingly. The attribute bind, C, is used to achieve compatibility between Fortran's derived type and C's struct. A Fortran derived type with the attribute bind, C, cannot have the sequence and extends attributes. Furthermore, it cannot contain any Fortran pointer or allocatable types. Parameterized declaration list is an optional feature. If used, then the parameters must be listed in place of parameterized definition statements and must be either len or kind parameters or both. The attribute extends introduces an important feature of the object-oriented paradigm, namely inheritance. It allows code reusability by letting child types derive from extensible parent types. Type extends parent, child. Here, child inherits all the members and functionality from type, parent. member variables refers to the declaration of all the member data types. These data types can be of any built-in data type and/or of other derived types, as already showcased in the above examples. However, member variables can have their own extensive member attributes, name, a trie-dependent spec init type, any built-in type or other derived type member attributes, optional, public or private access attributes, allocatable with or without dimension, to specify a dynamic array pointer, codimension, contiguous, volatile, asynchronous. A derived type can contain functions or subroutines that are bound to it. We'll refer to them as type-bound procedures. Type-bound procedures follow the contains statement that, in turn, follows all member variable declarations. Derived types help us to introduce the concept of object-oriented programming. OOP help us to represent data as general classes that could have some attributes, member variables, and could realize certain tasks, type-bound procedures. Instances of this classes are called objects. In the next video, we would see some examples of these topics. Thanks for watching this video. Don't forget to subscribe to our YouTube channel. See you in the next video.